So today I'm going to tell you how to calculate sample sizes for different study designs. Main thing is that what the sample size calculation requires is that you give an estimate, an educated guess of what your results are going to be like. For example, if you are comparing means between two groups, you have to give an estimation of what you think your means in the two groups would be like. If you're comparing proportions, then you have to give an estimate of what you think your proportions are going to be like in the two groups. If you're going doing a correlational study, you have to give an idea of what you think your correlation coefficient would be. Where to get this idea from? Ideal thing is to first, in 10 to 20 samples, run a pilot study, apply statistics on it, and the values of means or proportions or correlation coefficient that you get from those, add those to the relevant formula. If not, what we try to do is find the closest study which has been done to our own research question. And this, because we might be replicating in most cases, sometimes a study has taken place in Europe or America, and we want to validate it in our part of the world. So we know if we can apply those results in our country, on our people. And usually that paper is available and we can use the values from the results of that paper. I'm going to share different websites with you where those values can be applied and sample size can be calculated. All right. So as you can see, this is a website and there are many others. This is one example of a website which compares, gives you a sample size for descriptive studies. If there are descriptive studies where you are just maybe, for example, describing the typical symptoms of a migrainous patient from your population, from local population, and you want to publish that. You want to find publish clinical findings from a typical disease, from a disease from your part of the world, right? In that case, you just need one information, and that is what is the prevalence of that disease in your country, in your population. This is what the information which is required. Margin of error, do you need it? Keep it at 5%. Confidence level, keep it at 5%. They are given. How big is the population? Means, for example, if I want to document a migraine patients, their triggers or their symptomatology from my part of the world, then my target population are all the migrant patients from my country. Usually this information is not available. And as this website says, we use the value of 1 lakh over here. So just put 1 lakh over here. This is where we want our prevalence to be. If we are looking at a common disease like migraine, there was a study conducted in my country where it was found that every third young woman has migraine. So I put in 33% as the prevalence or the sample proportion to be. And you can see that the recommended sample size is 339. If I'm looking at a rare disease whose prevalence is, say, 10%, you can see that the sample size has come down to 139. Even a rarer disease, say with a prevalence of 2%, and you can see that the sample size has come down to 31. So for a descriptive study, we use prevalence of that disease as the statistic to be put in the sample size calculator. The more common the disease, the higher the sample size. The rarer the disease, the smaller the sample size. Second example is of, let me share again. Okay, so sometimes we are comparing proportions between two groups. For example, we have a study in which we want to compare the number of people, suppose, who are obese between two groups. One is insulin resistant and one is insulin sensitive. And this is the study we want to carry out. And we take a similar study from another part of the world and we note it. And we note what were their results. Proportion of obese patients in their insulin resistant and non-resistant groups. We usually find multiple papers, and I will tell you which paper to choose to get a better sample size, more manageable sample size. Again, what these softwares require: confidence level, keep it at 95. Power 80 is acceptable. Sometimes they want 90, so add 90 if that is the requirement from your university. And this is where we put the proportions from that paper. Suppose that paper said that in group 1, insulin sensitive, they had 30% people who were obese, and in insulin resistant, they had 80% people who were obese. Now, this shows that you require 12 people per group to get a good sample size. And to justify your results of your study. Now, if I find a paper which says 60 and 70% proportions in both groups, you can see that the sample size has risen a lot. Bottom line is, the less the difference between the proportions in the two groups, the greater the sample size. The more the difference between proportions in the two groups, the smaller the sample size. So you choose a paper which shows more difference in the two groups. We come to another scenario. More often than not, we are comparing means between two groups. For example, one might be comparing, I'm going to give very simple examples. Of course, your researches would be more complex than that. Suppose somebody is comparing C-reactive protein between COPT and non-COPT groups, and it has never been done in your population. So you take a paper from one of the other countries where this research has been done and use the findings from that. Or you would have carried out a pilot study to get those samples. So what does this calculator require? Expected means, mean of the reference group and the test group. So just one group and the other group. Suppose in one group, the value of C-reactive protein was 100. In the other group, the value of C-reactive protein was 120. Standard deviation was 50. And we calculate the standard deviation would be what comes after the mean. You know, it's written 100 plus minus 50. So 50 is the standard deviation. There will be two standard deviations. To be on the safe side, you take the bigger standard deviation. Now we calculate, and we find that in this case, the sample size of 99 per group would be required to get good results or proper results from your study. Now, suppose you think this is too much, you find another paper where the difference between the two groups was even greater. In one group, it was 100. In the other group, it was 50. And the sample size and with this, the standard deviation was, say, again, 40. The bigger sample size, 100 plus minus 40. Let's calculate. And now you see that the sample size required is 11 per group. Again, the bottom line, the greater the difference between the means of the two groups, the smaller the sample size that you need. In each of these sample size calculators, you will find a link where they will also give access to your to the formula they have used if you need that. I'll come to another example now. Suppose we want to calculate, we want to do a correlational study, cross-sectional correlational study, in which we want to take a sample and we want to, say, correlate. Again, I'm going to use a common example, body mass index with insulin sensitivity in our local population. we want to do that. So we're going to find a paper, one of the international papers, which has already done that. Means given the value of correlation coefficient between insulin sensitivity and body mass index. So we take that paper. Of course, there will be multiple papers. Take the paper which shows the highest correlation coefficient. Alpha will be the same 0.05. Beta should be the same 0.20 if you need the power of 80. If you need the power of 90, then this will become 0.10. Correlation coefficient, if it's small, like suppose it is 0.30, and we calculate, you will see a sample size of 85, which is required. Let's put a larger correlation coefficient, 0.70, and you can see that a smaller sample size is required. This is the reference which you can use if you want to quote that where you calculated the sample size from. And if you open this reference, you will find the formula that they have used as well. Last of all, I will tell you what to do when you have a case control study. In case control study, you often require odds. The statistic of choice is odds ratio. So we open a calculator which requires odds ratios. You just reach these calculators by typing on Google sample size calculator for odds ratio, sample size calculator for comparison of mean, sample size calculator for comparison of proportions, and you will get a number of calculators you can use. As you see, for all practical purposes, I'm going to tell you leave precision at 50, leave confidence at a level at 95. Usually 95 is required. And this is expectant prevalence of outcome in your absence group. Over here, when you take the paper from where you are taking your the case control study, which you're taking as a reference, you will take the control group and you will see the proportion of people with the risk factor in the control group, and you put that here. I'll give an example. Suppose you're taking a case control study of smoking and COPD. You take COPD and see the proportion of smokers. You take cases and you see the proportion of, you take controls and see the proportion of smokers. Here you will put the proportion of smokers in the control group, or in the, in this case, then the non-COPD group. And then you add the odds ratio over here. Suppose you find the odds ratio to be 2. You see the calculated sample size for the absence means control group is 262. So you, as the sample size, as your odds ratio grows, for example, your odds ratio is 15, you can see that the sample size is reduced. If the prevalence in your control group, say, increases, it's 18%, and your odds ratio is higher again, say 20, then you can see that a smaller sample size is increased. And here we keep 1 because we usually take 1 case versus to 1 control. So this is how you calculate sample size for your different study designs. Just use your online calculators. You should know the kind of study design you're using. Take a relevant paper, values from that relevant paper, and put it in your calculator. You will, and usually these calculators give a reference from where you can get the formula, or if you scroll down, they will have the formula written on the website which they are using.